All right, so now we're going to be looking at direct and inverse variation. So a little bit about the direct variation. Direct variation is something that we have covered in Algebra 1. So we're going to just review it a little bit, and then we're going to kind of move on and look at some inverse variation as well. So with direct variation, the equation just looks like y equals ax. Okay, so looking at this, realizing here, I'm not adding or subtracting anything, so we're not going to have adding or subtracting, and your origin is always going to be gone through with this line. So if I were to graph a direct variation, it's always going to go through the origin. Your y-intercept is always at that 0, 0. So a straight line goes through the origin of a graph. This is the big concept of what we're going to concentrate on today is the equation. And looking at the a value, this is called your constant of variation. And if we look at this, so realize in my direct variation, my equation, I have y equals a times x. So here I am multiplying in my equation. For inverse variation, it's going to be the opposite of that. So for my inverse variation, it is going to be y equals a over x. So we are dividing a by x. Again, this a is still my constant of variation. So the terminology is the same, whether it's direct or inverse variation. And looking at the big thing about inverse variation, this x value right here cannot equal 0 because I can't have 0 on the bottom of a fraction. So unlike direct variation that does go through the origin, here my x value cannot equal 0. Okay. So again, biggest concept for what we're going to look at today is we're going to have to be able to find that constant of variation for either one of these equations. All right. So we're going to look at it first and make sure you can look at an equation and say, is this direct or inverse variation? Or it could possibly be neither. It doesn't have to be one of those. So the way that you're going to do this is we're going to get y by itself, because when I look at my equations, I have y by itself. So I'm going to solve for y. So looking at this, if I want to get y by itself, I have to move that x over there. So I am going to divide by x. So I get y equals 7 over x. So looking at this one, this matches my inverse variation because I am dividing my a value by x. So this would be an example of inverse variation. Looking at this, y is already by itself. Notice here, I am adding 3. Neither one of these equations have any adding or subtracting. So realize when I'm doing direct or inverse variation, there is no adding or subtracting. So as soon as I see that, I know that's going to be neither. So that one doesn't represent direct or inverse variation because of that addition. And then here again, if I want to get y by itself, I'm going to move the 4 over here. They're dividing by 4, so I'm going to multiply the 4 over there. So that's going to leave me with 4x. And when I look at that, that matches my direct variation. So this is what that is an example of. So just making sure the first concept that you can tell the difference between what an equation is, if it's inverse, direct, or neither one of those variations. So if you're doing that, all you're doing is you're solving for y. So get y by itself and see what your equation looks like. Okay? Now, for the next couple, we are going to actually write the equation, and then we're going to use that equation to find different values. So it's going to tell you in the directions right here whether it is direct or inverse variation. So for this one, it says if x and y vary inversely and y equals 7 when x equals 4, that we want to write the equation. So remember, my inverse variation equation looks like this. Y equals a divided by x. So I have to find my a value. So the first thing I'm doing is taking these numbers and I am plugging them in to find a. So it tells me y is 7 and x is 4. So I'm going to plug those in for my x and y right here, and then I'm going to solve for a. So if I want to get a by itself, I have to move the 4 over there by multiplying it. So that tells me my a value is 28. So make sure this says write the equation. So my equation would be y equals 28 over x. We always have to be able to write the equation. Okay, so now the second part of this, it says use your equation to find, that should be find, y when x equals -2. So now it's giving you a specific number to plug in for x. So for the second part of this, I'm using my equation and I'm going to plug in a -2 for that x value. So I'm just going to do 28 divided by -2, which gives me a -14. So that's the second part of the problem. All right, the first part, I have to be able to write an equation. Second part, I am using that equation to find a certain value. So let's look at the next one. So again, it's varying inversely when y is equal to -1 and x is equal to 8. So those are the two numbers I'm plugging in. So looking at this, my y value is -1, my x value is 8. So now I'm going to use that. I'm going to solve for a. So 8 times -1 is -8. So my equation should be y equals -8 over x. So that is my inverse variation equation. So now I'm going to use that to find out when x is 2, what's your y value? So looking at that, I'm going to plug in a 2. So if I do -8 divided by 2, I know that equals a -4. All right, so again, make sure you're just taking the numbers they're giving you, plugging them in. You're going to solve for a, and then you should be able to write your equation. All right, the next one is a word problem. Looking at the word problem, same concept. So looking at this, the number of photos that can be stored on an SD card varies inversely. So again, that's going to be the keyword, with the average size of the photos in megapixels. If the photos have all have 4 megapixels, then the SD card can store 2,228 photos. So write the inverse variation equation first. So again, remember, I'm still writing this equation, and I need to figure out what my A value is. So looking at this, my stored photos, and it tells you right here the number of photos can be stored. That on an SD card varies inversely with the average size. So looking at that, my Y value is the 200 or 2,228 equals A over the 4 megapixels. Okay, so if I want to solve for A, I'm going to have to multiply that by 4, pretty big number. So we are going to multiply 2,228 times 4. So that's going to give me the 8,912. So that's your A value. So when it says write the equation, remember my equation is y equals, I'm going to have 8,912 over x. So that would be my equation. So now the second part, we are now going to use our equation and plug this in. So how many photos can be stored if they all have 22 megapixels? So remember, this is my x value, and the photos were my y values. So looking at that, I'm plugging that in for x. So I'm doing 8,912 divided by 22. And when you type this in your calculator, you should get, so we're going to do 8,912 divided by 22. And so you do get a decimal, and we're talking about photos. So we are just going to round that. So that's going to be about 405 photos. So in a word problem, they should tell you what your x and y are going to represent. Same concept as what we did up here. You're just taking those values, plugging them in so that you can solve for A. You can write your equation, and then we're going to use that equation to solve. All right, so we were just given numbers to plug in. So we were given an x, we were given a y. So now we have to look at, well, if I give you a table, you have to be able to tell me whether it's an inverse, a direct variation, or if it's neither. So same concept here, but instead of equations, we're going to look at tables. Okay, so looking at this, if I look at the tables, there's something you're specific you're going to be looking for. So the rule is, if I am dividing your y values by your x values, that is going to be an example of direct variation if they're all the same. So when I'm dividing my y values by my x values, if they're all the same, it's going to be an example of direct variation. If I am multiplying your y by your x and they're all the same, that is your inverse variation. So you have to look at what the operation to get them is the same. So if you're dividing to make them the same, that's direct variation. If you're multiplying to make them the same, that is your inverse variation. So if I look at the first one, so if I look at 2 times 12, I know that would give me 24. Okay, and if I'm looking at it, if I was trying the dividing, I could do 12 divided by 2 would give me 6, but is 6 divided by 4 also 6? No. So 2 times 12 is 24, Multiplying 4 times 6 is 24. 6 times 4 is also 24. And the last one, 8 times 3 is 24. So all of these worked with multiplication. So when I multiplied across, they all equal 24. So if I am multiplying them, that means that's an example of the inverse variation. So that would be an inverse variation. And if I ask you, write the equation of this table, for this one, the number that they multiply, that's your A value. So that means this would be 24 over x. So that would be my equation for that inverse variation table. Okay, so let's look at the next one. If I start the multiplication, 2 times 10 is 20, 4 times 8 is 32, so that doesn't work. So that's not, the multiplying one doesn't work, so that's not an inverse. So let's try the division. So if I do 10 divided by 2, I get 5. But then 8 divided by 4, I get 2. So that doesn't work. So that means this is an example of neither. So that's not a direct or an inverse variation. All right, here, so let's try the multiplication. 3 times 6 is 18. 5 times 10 is 50, so that doesn't work. So let's try the division. So 6, remember we're doing it this way. 6 divided by 3 is 2. 10 divided by 5 is 2. 14 divided by 7. And then that 18 divided by 9 also gives me 2. So they all equal 2. So this, because I was dividing, is an example of direct variation. All right, and again, this is my A value. So if I'm writing the equation, this would be y equals 2x. So realize it might look a little weird because here, when I write my inverse variation, it's a division. It's 24 divided by x. But what I said in your table, you're multiplying and it equals the same. Because if I look at this, if I plug in these numbers, 24 divided by 2 is how you get the 12. 24 divided by 4 is 6. 24 divided by 6 gives me the 4. So that's why it's kind of like the opposite of what your equation is. Same thing here for direct variation. If I plug in these x's, 2 times 3 gives me 6. 2 times 5 is 10. 7 times 2 is 14, and so on. Okay, so for the tables, you want to look at whether you are dividing the x and the y's or if you're multiplying the x and y's together. All right, last concept, joint variation. So we've done direct and inverse variation. So now we have joint variation. Basically what that means is you're going to be adding in another variable. So this equation is going to look a little bit different. So now we're going to introduce a z. We still have your a, so this is still your constant of variation. That's not changing. Okay, so that a value is still your constant of variation, and x and y are being multiplied over here. Your a value cannot equal 0, because if it equals 0, it's going to cancel everything out. We don't want that a value to equal 0. Okay, so this is going to be what a joint variation looks like. Again, it's going to be combining what it means in a way you can word it. So this means it varies directly with a product of 2 or more variables. So it's going to vary directly with a product of 2 or more variables, because realize this is very similar to direct variation where it's just y equals a times x. We just threw in another variable. So now we have x and y on this side, and you still have that constant of variation. So when I write the equations right here, it's going to be very similar and the same to what we were doing on the front page. So if I'm looking at this one, and again, it's going to tell you the directions. So this one says it's varying jointly with x and y. So if this is my equation, I'm going to plug in the numbers that they're giving me to find my constant of variation. So z is negative 75. A, I don't know. I'm trying to find. X is 3. And your y value is negative 5. So all I did was take those 3 numbers and plug them into that set equation. So now I'm going to multiply. 3 times negative 5 is negative 15. And then to figure out what a is, I'm going to divide by negative 15 on both sides. So here, when you divide by negative 15, you know your a value is 5. So now I can write my equation. So remember my equation, I'm going to have this variable in it. So z equals, my a value was 5 times xy. So that would be my equation. Okay, so very similar to what we did on the front side of the notes. And then here, you're going to use it, and I'm going to give you 2 other values. So I'm going to find z when x is 2, and y is 6. So that means I'm plugging those in. So my constant of variation is 5, my x value is 2, my y value is 6. So I'm just multiplying all these together. So here, 5 times 2 is 10, 10 times 6 is 60. So that's what z would equal. So another one, very similar to this, okay, varies jointly with x and y. So again, it's going to give you those 3 values. So I'm taking those 3 values and plugging them in, and I am solving for a. So looking at this one, I think I changed the numbers earlier to make this work a little bit better. I did. So let's change these numbers. So we're actually going to change this one to a 5 and this one to a 2, I believe. -2. Yep. So there we go. So we're going to change these to make them actually work a little bit better, because that one was going to give us some really bad fractions. And we don't want to work with those. So let's change this. So 5 times 2 right here is the -10. And if I divide by -10, your a value is a -1/2. Okay, so that's a little bit of an easier fraction to work with. So if I write my equation, my a value is that -1/2. So this would be my joint variation equation. Okay, so now I'm going to look at this and say, okay, now I'm going to take these two numbers and plug them in, and I'm going to solve for z. So your x value is 4, your y value is 160. So if I look at that, -1/2 times 4 is -2, and then -2 times 160 is a -320. So there you go. So joint variation, again, you're just kind of adding in an extra variable. It looks very similar to direct variation. You're still going to solve and write that equation by solving for a first. Okay. Now the last little part, you could just see some problems where it's asking you to write the equation, and it's going to give you some different directions. So looking at this, the key part is you're going to have to see whether it says if it's inversely, if it's jointly, or if it's direct. So that's going to be the key part. So here you only have 2 variables, and it says y varies inversely with the square of x. So because it says inversely, I know I'm dividing in my equation. So I'm going to have a divided by the square of x would just be x squared. Okay, so they're just giving you a little bit more terminology right there, that vocabulary. But the key part, inversely, I know I should be doing a divided by whatever my x is. Okay, here, if it says z varies directly with y and inversely with x. Okay, so directly means I'm multiplying by your a value. So this is always going to be the equals. So directly, that means this y is being multiplied by your a. Inversely means you are dividing. So anytime, again, with direct variation, I should have the multiplication. So if it varies directly with y, that means I'm multiplying times a. The inverse means I'm dividing by x. Okay, so let's look at this one. X varies jointly with n and m. So again, keyword, jointly, and inversely with p. So right here, jointly means I'm going to be multiplying the n and the m. Inversely always means the division part. So anytime you see inversely, you know that's the part that's dividing. The direct variation should be multiplied by a, and the joint is being multiplied by a. Okay, so x varies inversely with the square root of y. So if I look at this one, if it's being inversely inverse variation, that means I am dividing by the square root of y. So key parts here, look for your terminology. Anytime it says if it's varying inversely, that's being divided on the bottom. So this was inversely with x, that x is on the bottom. Inversely with the square of x, x squared is on the bottom. Inversely with p, p is on the bottom. Inversely with the square root of y, that square root of y is on the bottom. So anything that's inversely with that variation, that is on the bottom. And then the direct part, or the jointly, that is being multiplied on the top with your a value. Okay, so again, key part of this is making sure I can write those equations, and then you can identify whether a table is inverse or direct variation and whether an equation is an inverse or direct variation.